Okay, we're going to use some trigonometry to find missing sides or angles in these right triangles. On number 43, we've got a 24-degree angle. X would be the opposite leg. It's across the triangle from the 24. 19 is the adjacent leg. So this problem has nothing to do with this side, which is the hypotenuse. The only trig ratio that uses opposite and adjacent legs is the tangent ratio. So we're going to write that the tangent of 24 equals x over 19. Well, we're going to solve for x. We're going to multiply both sides by 19 now. I'm going to lose SOHCAHTOA there for a moment. And that will give me, when I multiply 19 over, that x is equal to 19 times the tangent of 24. So at that point, we just grab our calculator and type in 19 tan 24, hit enter, and we get to the nearest tenth, which is what the problem asks for. We get 8.5. Okay, on number 44. We want an angle this time. We have the hypotenuse. The 12 is the opposite leg. Only the sine ratio uses, if I write SOHCAHTOA again up here, SOHCAHTOA, only the sine ratio has opposite and hypotenuse in it. So we'll write that the sine of x is 12 over 17. When we want to know the angle, we use the inverse function. X is the inverse sine of 12 over 17. So I'll use the second button on my calculator. Second sine will get the inverse sine. 12 divided by 17, put that in parentheses, hit enter. To the nearest tenth, this is 44.9 degrees on number 44. Okay, on problem number 45, we have an angle. We do not have the opposite leg. We do have the hypotenuse, and we'd like to find the adjacent leg. Well, back to SOHCAHTOA, cosine uses adjacent and hypotenuse, so that's what we're going to have to use. So on 45, we're going to say that the cosine of 62 is x adjacent over 60. Just multiply by 60 now. X will be 60 times the cosine of 62. Put that in your calculator. 60 cosine 62 to the nearest tenth is 28.2. Okay, problem number 46 here. We've got a 31-degree angle. This is very much like 45 up there. We know the hypotenuse, and we'd like to know the adjacent leg. So again, adjacent and hypotenuse has to be cosine again. So cosine of 31 will equal x over 34. So x will be 34 times the cosine of 31. Again, just put it in your calculator. 34 cosine 31. And we've got 29.1. That was number 46. On problem number 47, we have an angle, 17 degrees. We know the opposite leg. We'd like to know the hypotenuse. Well, that's the sine ratio that uses opposite and hypotenuse. So we will say the sine of 17 is equal to 6.6 over x. Remember in class we said that whenever x is in the denominator, It's actually a two-step algebraic process, but we can just end up with a division problem by switching those two. So x will be 6.6 divided by the sine of 17. 6.6 divided by the sine of 17 is 22.6. And on number 48, we have an angle that we're trying to find. We don't have the hypotenuse, but we've got the opposite and adjacent legs. We'll be using tangent. Tangent is opposite over adjacent. So that's the tangent of x is 15 over 18. That, when we want to know the angle, we use the inverse function. X is the inverse tangent of 15 over 18. To the calculator, second tan gets me the inverse tangent. 15 divided by 18, in my parentheses, hit enter, and we've got 39.8. The last of your homework problems was a word problem involving an airplane. And it said a plane is 1 mile above sea level when it begins to climb. So it's a mile up to begin with. It ascends at a 3-degree angle. It starts to climb for the next 60 miles. And what we want to know is, after that 60-mile climb, about how far above sea level is the plane after its climb? Well, we're going to put an X here because that's how much it climbs. So whatever we get for X, we'll add 1 to it, and that will be our answer. All right, again, this is going to be a tangent problem. A lot of applied problems are. We'd like to know the opposite. This would be adjacent. We don't have any information on the hypotenuse. So we're going to say that the tangent of 3 degrees is equal to x over 60. That means that x will be 60 times the tangent of 3. Just grab the calculator. 60 tan 3 is about 3.1. So the answer is that if this is 3.1, the plane is 4.1 miles above sea level after the climb.